is a review of the Edgenuity lesson, Special Right Triangles. So when the video first starts out, they start talking about 45, 45, 90 triangles. And when you have a 45, 45, 90, that means these two angles are both the same, they're both 45. So the sides that are opposite them have to be the same. So opposite that 45, opposite that 45. So that's what they were talking about when they're saying it's an isosceles right triangle. So when you're doing 45, 45, 90s and you're solving for side lengths, this is the way that I think of it. I just put on the legs, I put empty boxes. And on the hypotenuse, I do an empty box times the square root of 2. And the reason I do that is because if I know what the leg is, if this is 4, then I'm going to put a 4 in there, and this was going to be 4 root 2. Or if I knew that this was 10 root 2, so if there was a 10 inside that box, we can just take off the root 2 and put a 10 there and a 10 there. The part where it gets tricky is if in this box root 2 thing, you have a value here, but there's no times root 2 that you can just pull off, which I'll explain to that when we get there. So in this first example, it says find the value of x. So what we have, the legs get the box. And what we're solving for, this is in box times the square root of 2 spot, because it's opposite the right angle, just like this one is. So if this side is 3 and this side is 3 and those are in the box, then this value here is going to be 3 root 2. On the second one, we have x, x, and 10 root 2. So this one is in the box root 2 part. And the legs here, oops, I forgot to put a 45-degree symbol there, is just in the box. So if we know the hypotenuse is 10 times the square root of 2, we can just pull off the root 2, and we know that both side lengths here will be 10. Now this last one on the 45, 45, 90, this is what the one I was talking about where it gets kind of tricky. The 5 is in the position where it should be box times the square root of 2. And unfortunately, the 5 doesn't have a root 2. We can't just pull it off and then say these two lengths are 5. They can't all be the same. So what you can do is pretend this is kind of like an equation and solve it. We're solving for the part that goes in front of the root 2, the part that's going to be these two, the box by itself. So if I am solving for the box, I just divide both sides by the square root of 2. That cancels. Now, you cannot have a square root in the denominator of a fraction. You have to rationalize the fraction. And the way you do that is you just multiply the top and bottom by whatever the radical in the denominator is. So since it's square root of 2, I'm going to multiply the top and bottom by root 2. And what we end up in the top, if we just go straight across, we end up with 5 root 2. And then root 2 times root 2 is 2. And that'll always happen. So just as a side example, if I had like root 11 times root 11, it's 11. Or root 20 times root 20, it's 20. That's what happens every single time. So after solving that little equation, I know that the two x's here in the position of where it's just a box by itself, that value is 5 root 2 over 2. Like that. Okay, so similarly doing that type of method with the 30, 60, 90 triangles. So the side that's opposite 30 degrees, down here, that's just, if you have this value, finding out the rest of the triangle is super easy. So the hypotenuse is just 2 times that value, and the longer leg is that value times the square root of 3. So if this was, let's say, 6, this would be 2 times 6, which is 12, and this would be 6 times root 3, which is just 6 root 3. So like I was saying, if you have this value here opposite 30 degrees, filling out the rest is pretty easy. Really the only one that's difficult is if you end up with, you get this value and you're solving for the other two. Okay, so let's look at these 3 examples. So if this is our 60-degree angle, that means this is the 30 degree. So opposite 30 is our box. The hypotenuse is 2 times the box. And the longer leg opposite the 60 is box times the square root of 3. So what do you know? It is a 6. I'm going to go ahead and change that value really quick so that we do something different. Let's say it's 4. Just changing that up just because I already did a 6 up there. So we know the box is 4. So y is going to be 2 times 4, which is 8. And x is going to be 4 times the square root of 3, which is just 4 root 3. There. Okay, so on the second one, opposite 30 is the box, so we don't have that value to fill in for everything else quite yet. The hypotenuse is 2 times the box, and the longer leg is box times the square root of 3. So if I know that 18 is 2 times the box, that means the box on its own is 9. So this value here for x is 9. This value here for y is 9 root 3. Like so. The last one, opposite 30 degrees is the box. Y is 2 times the box. And opposite the 60 degrees is box root 3. Okay, so on this one, this is the one I was talking about where it's going to be the most tricky. But right here we have what we know. We know that this length is 5. We can set this up as kind of an equation and say box times the square root of 3 equals 5. And solve for what the box is on its own. So I'm going to divide both sides by root 3. And just like we did on the last page, we have to rationalize that denominator. So our denominator is root 3. So I'm going to multiply the top and bottom by root 3. If we go straight across, that gives us 5 root 3 over 3. So again, that's just the box on its own, this one here. So then for y, we have to do 2 times that box. And remember, 2 as a fraction is just 2 over 1. By fractions, we just go straight across. So our y value there is going to end up being 10 root 3 over 3, which you cannot simplify.